All right, folks, welcome to this Weather West live stream. Apologies for the slight delay there. As always, software chooses the absolute worst possible time to do automatic updates, whether you like it or not, right in the middle of the working day. So thanks for joining me. Obviously, quite a bit of interest today, as you can see with the numbers of folks who are live. Thanks for joining live, by the way. We're nearing 15,000 subscribers on the Weather West channel, which is an impressive number that I'd like to get up as high as we can, because I think YouTube is becoming a mainstay of my weather and climate communication. I think maybe even to a greater degree than I initially thought that it would be. So thanks for being here, and thanks for joining me today to talk about a surprisingly actually active weather pattern that we're going to see later this week in California and maybe continuing into next week as well. Not your typical September weather, I think it's fair to say. So far, as of the 16th, nothing too crazy, but for that big dry lightning event in Central California earlier in the month. But the last week or so has been a lot quieter. There's even some rainfall up in, especially northwestern California, but we could call it other parts of northern California. There were some light showers down into parts of the Bay Area. If you were in certain parts of San Jose, it might have even been a brief heavy shower. But generally speaking, nothing too dramatic, although there has been as much as an inch of rain in some parts of northwestern California the past couple of weeks, which is not fire season ending, even up there, but definitely is fire season mitigating, which is useful this time of year as we get closer to the rainy season, but potentially with additional heat waves and or wind events in between now and when the sustained rainy season starts. It is today pretty darn hot out there, all the way to the coast in some regions. There's a little bit of fog in a few spots right along the immediate coast, but generally speaking, it's a pretty hot day out there with some triple-digit temperatures inland and a lot of 90s elsewhere, even all the way pretty close to the coast in Southern California. Nothing particularly record-breaking, although there are a few places along the immediate coast in California that are near record highs right now as I say this, because that nearshore ocean is now, in some cases, record warm for the time of year. I'll talk about that today as well. But the big story right now is that there is a tropical storm off the coast of Mexico. Actually, I believe it has diminished into a tropical depression, so it has weakened considerably and is pretty shortly not even going to be that. It would be a remnant low. But the main consequence here is not so much the organization of the storm. It's already spinning down to a swirl of mid and low level clouds with some isolated thunderstorms. But the more consequential piece here is the moisture, the tropical moisture, that's going to enter California from the south, starting late Wednesday and then continuing really throughout the weekend and maybe being even reinvigorated early next week by a secondary wave of subtropical and tropical moisture. So the long and the short of it is, there is probably going to be some very active weather, certainly some very chaotic skies, and probably some pretty widespread thunderstorm activity in different parts of California later this week. That's about the extent of the confidence I have in exactly how this is going to play out. It's actually a very, very complex pattern. The weather models are still fairly literally all over the map with how this might play out, except that all of them are indicating that some part of California, most likely central and southern California, but maybe even somewhere else in California, will get hit with a pretty widespread and fairly prolonged period of showers or thunderstorms, and that there could be multiple waves that continue into early next week, as I mentioned. So we've got the hot weather now. It's pretty humid. It's muggy hot weather. It's really warm at the coast thanks to those very warm ocean temperatures. Now we got some tropical moisture coming up from the south. It's going to bring some unusual weather in the form of thunderstorms. Yesterday, and the day before, there was pretty elevated concern regarding the potential for dry thunderstorms, particularly the farther north that you go. We see this often in these similar patterns where there's a deep tropical moisture source, but a very dry air mass, that it is sort of butting into from the south. And on the far southern edge, the moist edge of the air mass, the thunderstorms you get are wet storms. You get traditional thunderstorms with heavy downpours of rain. You can still have wildfires that start from wet storms, but it's less likely, as you might expect, than with dry thunderstorms, which is essentially lightning with little or no rainfall. But the problem can be on the northern fringes of these sorts of deep tropical moisture outbursts associated with tropical storms or hurricanes or anything else like a monsoonal surge. The challenge can be is you can get a very large amount of moisture in the atmosphere, the full atmospheric column. But if most or all of it is above the surface layer, so you have a lot of mid-level moisture and a lot of upper-level moisture, but the surface is still very dry, what you can get is an atmosphere that is quite capable of producing convection, deep moist convection, which is the technical term for thunderstorm-like clouds, the tall cumulus clouds, essentially. You can get an environment that's quite conducive to seeing that kind of convective activity in thunderstorms, and that can even produce significant rainfall in the cloud above the surface. But often this will be what's known as elevated convection, meaning that it has a base, so it is vertically elevated. The bottom of the cloud might be 10,000 feet above the surface. Unlike a more typical thunderstorm where the base of the cloud would be between 1,000 and a few thousand feet above the surface for a typical thunderstorm. But this could be 3 times higher in the atmosphere. What that means is that if the bottom of the cloud is 10,000 feet up, and that bottom 10,000 feet is very dry air, that even if you've got very moist air and heavy rain falling from a thunderstorm cloud that's based at 10,000 feet, that heavy rain's got to fall through a 10,000 foot layer. I mean, imagine how tall a 10,000 foot mountain is. That's a tall mountain. Imagine if the water's going to fall through that full layer, and every few hundred feet more and more water is evaporating on the way down, back into the air because it is so dry. That is a classic recipe for dry thunderstorms, elevated convection with a dry layer near the surface. The rain may be falling from the cloud, but it's not enough for most of it to reach the ground. That's what happened, certainly, in 2020, in August 2020, with the remnants of former tropical storm or former hurricane Fausto, when we had that extreme dry lightning outbreak and the subsequent devastating wildfire siege across Northern California in the wake of that event. There's several reasons why I don't think we have a similar situation right now. The most important of which, because I'm 100% sure that it will remain true for the duration of the event, is that we do not have severe drought conditions in place in Central or Northern California like we did in the summer of 2020. In fact, fortuitously, it's one of the few parts of the western U.S. that is not experiencing a severe to extreme drought at the moment. So the places in California that are most likely to get dry lightning from this event, and I think the odds have actually decreased a bit since yesterday, but it's still possible, would be from about the Bay Area southward to portions of the Central Coast. Now, the reason why that's good news is that it means that if there is dry lightning, which again, it could still definitely happen, and there could be fires, but the per lightning strike rate of wildfire ignition would be a lot lower than it would be during a severe drought. And also, and this is the most important part, the consequences of fires that might ignite will also be lower because they will have a lesser propensity to spread quickly and to burn intensely than they would in a different environment that was much drier, as it was in August 2020. And August 2020 really was the perfect storm. We were in a severe drought. It followed a really extreme heat event. And in this case, we just don't have that drought precondition in Northern and Central California where the driest lightning might occur during this event. Secondly, in Southern California, there's going to be a pretty high chance of lightning. In fact, probably a higher chance than in Northern California. But except for the very initial storms in the first couple hours, which could be on the drier side, these will probably be wet thunderstorms in Southern California. There's plenty of moisture in the atmosphere, though more likely to produce heavy downpours. Still possible we could see a few wildfire ignitions, but the risk is decreased relative, of course, to dry storms. And here again, the air mass itself will be relatively moist in Southern California. So what fires might ignite? They could either be extinguished by rainfall pretty quickly, which would be the best outcome, or otherwise they're not necessarily occurring in an extremely hot or windy or low humidity environment. So again, the consequences would be relatively less. So this could be a significant fire weather event in Central and Northern California in particular, but it is not going to be an extreme one because we do not have that antecedent drought. Storms may start out dry if they occur from the Bay Area northward, but they may transition towards wetter later. And we also have a slightly lesser chance of storms further north, I think, than we did yesterday, but they remain possible. So I'll get into those details in a minute. So to suffice it to say, the long story short, the remnants of Tropical Storm Mario are headed north. They're definitely going to bring some showers and thunderstorms to some portion of California. In general, the odds are higher the further south you go, although at least a slight chance does extend well into Northern California, and that does include the coastal and valley regions, not just the mountains this time. There is a chance that some of these storms could be dry storms or drier storms, especially as you get north into the northern central coast in the Bay Area and in the initial days of the event, though that's pretty low confidence. So there could be some wildfire starts. We could be talking about those, but I don't foresee this as being a particularly extreme fire weather scenario. It's in the tail of the possibilities still, but it's probably not the most likely outcome. Southern California is more likely to see scattered thunderstorms that are wet, leading to heavier downpours. Could even be some flash flooding. So with all of that said, this is an extremely complicated pattern, and I'll show you exactly what that looks like. It's pretty obvious from the chaotic motions of stuff in the atmosphere. And frankly, I don't know exactly what's going to happen, except that I would be very surprised if the week ended without some thunderstorms in some coastal parts of California. Exactly what those look like, whether they bring heavy rain or barely any rain, whether they cause some localized flash flooding or some fire starts, it could be either, could be both. It's hard to pinpoint, and I'll show you why in a minute. One thing I wanted to begin with, I'm actually going to share my screen now because I think there's a couple of things that will be helpful to illustrate right from the start. And I talked about this in the last live stream, so you should be seeing a map of global sea surface temperature anomalies, meaning the relative unusualness of the warmth of the surface ocean the world over. And there's three things I want to draw people's attention to on this map. So I did talk about this last time, but I want to reemphasize it because if anything, it's gotten even more dramatic. And that is to say, let me choose a color here since this is a very colorful map. I'm going to choose magenta again since it's a nice contrast. Three things. Look at the whole map. The whole map, save for this one region of coherent blueness in the tropical East Pacific, the whole map is yellow, orange, or even red and black. That means that essentially all of the global oceans, except for really this region here and a couple other much smaller patches, are much warmer than average. So the global oceans are very warm right now. Secondly, take a look at the North Pacific specifically and the North Pacific Rim. So if you think about the entire coastal region of the North Pacific Ocean, all the way from China and Japan and Papua New Guinea, going all the way from north and east to Kamchatka and Russia and the Aleutian Islands and the Gulf of Alaska and British Columbia and the Pacific Northwest and California coast and Baja California and then the west coast of mainland Mexico, and then you go down even into Central America off the coast of Costa Rica. That entire region is now well above average. I don't think that that's ever happened before, certainly that I can remember, and indeed, if you draw a box and include the ocean areas in this region, they are collectively the warmest we've ever observed. So this is a pretty historic marine heat wave. It is extreme, especially from the northeastern China through this what's known as the Kuroshio extension. this warm water current in the West Pacific that extends east of Japan. Japan has had just record-shattering warmth and rain this summer, as I believe is, I actually haven't heard about the Koreas, but I would not be surprised if South Korea was reporting something similar, given how genuinely extreme the ocean warmth is in this region. But earlier this summer, this was mainly confined to the West Pacific, this region here, but it has, as I mentioned in previous talks, it has slowly expanded eastward and now extends all the way to the California coast, where, look at this warm blob right off the coast now of California, up to and including the coast itself. If you've been to the beach recently, anywhere in California, and this includes the cold ocean parts, even if you've been there in the fog is probably a solid 5 or 6 degrees Fahrenheit warmer than it usually is. I would hesitate to call it a hot fog, but it is a noticeably not biting fog. It's not like that 50-degree marine layer that you sometimes get on Ocean Beach in June or July. It's a 60, 65, even 70-degree damp air. And that feels very different than the kind of conditions that we're used to along the central and north coast in California. In Southern California, the water is actually even warmer, and so there it maybe feels a little more tropical. But if I zoom in a little bit, just to give you a sense of this, there's a couple of patches where there's a couple of cold eddies right along the immediate coast. But in general, I mean, look at this blob. We're now, and again, if I realize the units are cut off here, these are in degrees centigrade, so multiply by 1.8. So offshore and in this region by Cape Mendocino, where we're seeing those values that are up in the 4 degree centigrade range, well, multiply by 1.8 to get the Fahrenheit version of it. And then you realize that we're talking about ocean temperatures that are like 3 to 6 Fahrenheit above average. That's a really big anomaly in this region. So we have all this warm water offshore. We have an unusual amount of evaporation from this warm water offshore. And this does extend, by the way, off the coast of Southern California and going down the coast of Baja California, just off this map, as I mentioned. This is relevant for the current pattern because we have air moving up this direction towards Central California. So there is a contribution in addition to the tropical storm, which was down here, moving in this direction. Well, we also have it moving over warmer than average water. Now, this doesn't mean the tropical storm is reforming. It's still relatively cold water in absolute terms up here, but because it is so much warmer than average, there is more water evaporating from this surface ocean that's becoming entrained into this flow, and that's going to make it onshore with the pattern this week. It may also be influencing next week's weather, and as I've talked about before, potentially the fall, and if it persists, the winter to come as well. All right, let's take a look at satellite imagery because there's several interesting things going on. Let's actually take let's take a look at the goes west continental view. That might be not even big enough. Let's see if the global sector is better here. All right, well, here's a cool view of the Earth live from space. And it looks a little bit unusual for fall, honestly. Consider, for example, how much of Western North America is cloud-free. I mean, it's cloud-free. You can draw a cloud-free line from San Diego to the Northwest Territories of Canada. That's not very normal for mid-September. And that's not just, you can draw multiple lines that are cloud-free for several thousand miles here. At least a couple thousand miles. Let's call it several thousand kilometers since we're up in Canada. The other interesting thing is that you can clearly see on this map the decaying tropical storm that we're talking about. It's down here, as I mentioned, west of Baja California, and it's going to move to a position, or its remnants anyway, somewhere off the central coast. Exactly where is actually fairly consequential to the forecast. If it ends up more off here, we may avoid a lot of the onshore impacts. There may be less thunderstorms, although there'll still be some isolated storms. If it takes a path right up the central coast, that would probably maximize the amount of thunderstorms around the Bay Area and Northern California. And if it takes a more easterly trajectory, then that would, of course, as you might expect, maximize the likelihood of thunderstorms in Southern California. This is one of those cases, the steering flow, the winds aloft, if they were screaming westerlies, well, this thing would just recurve and be out of there really quickly. But there's really no significant winds to speak of, so the models don't have a really clear steering flow to latch onto, and really this could end up somewhere in here. Again, it won't be a tropical storm. This is not Hillary 2022 Redux, but it is still a fairly notable event in the sense that this will be long since past being a tropical system, but it's got a lot of moisture associated with it, and also there may be a fair bit of spin in the atmosphere that could give a little bit of lift to that moist air, and also a fair bit of instability. And that's the piece that's really leading me to believe there's a pretty high chance of some significant thunderstorm activity here. But let me zoom in on a couple of interesting features of interest. One is there are mercifully few wildfires going that are active in any form right now in California. In fact, really the only one where I can find noticeable activity is the Garnet fire, and even here the activity level is not nearly as intense as it was. We look at the thermal IR, we can see it here, but just barely. This is looking much better than it was a couple of weeks ago, and frankly, although it is still generating smoke and flame, that may be mostly interior burning. So short of a major wind event, this may be a fire that's on its way toward being managed. It probably won't be fully extinguished given where the remoteness and the density of the vegetation where it's burning, but this may, fingers are crossed, but that's pretty good news about the future of the Garnet fire. So I wanted to show that. The other thing I wanted to show is up in the Pacific Northwest, and this is very unusual. Look how clear the skies are, except for plumes of wildfire smoke in a few regions. So if you notice, there's a major fire burning on the Olympic Peninsula. It's been burning for weeks, sending smoke northward to Vancouver Island. There's also a couple of active fires in the mountains in central Washington, and all these will become a little bit more apparent with the thermal infrared imagery. So you can see again those black dots. That fire has really taken off in the last couple of hours, it looks like. But you can also see active hotspots over here and here. These twinkling, maybe solar panels actually, sun glint. But you can see the smoke plumes, otherwise crystal clear skies with offshore flow. That's not a very good arrow. Well, I guess you can actually use the wind as tracers. You can see the smoke plumes are kind of blowing like this. It's not pure east wind, but it is offshore flow since it's southeast and northwest near the surface. So we have clear air. You can see another wildfire down in Oregon. Really not typical to have this continued level of wildfire activity in the Pacific Northwest, although fortunately none of these look immediately threatening, but there will probably be, once the inversion sets in overnight, it's going to be another smoky night probably in western Washington, I would bet, after very clear skies in many places today. But this is unusual. This is an unusual pattern, and just another indication that some strange things are potentially afoot in the west. All right, so if I take a closer look at this decaying tropical storm, again, here it is. Let's take a look at the mid-level moisture in the atmosphere so we get a sense of how far north this moisture has made it. Right now, boy, this thing looks very unimpressive on mid-level moisture imagery. It barely even looks like a storm. It just looks like a swirl. Barely a swirl at that. We've seen better swirls this summer. But the center of circulation is somewhere around here. And the northern fringe of this mid-level moisture is maybe just getting close to entering Southern California now. Although there might actually be some, let's see if there's other indication. No, that seems about right. There's some upper level water vapor that's on the leading edge a little bit, but this is mostly still south of California. And I think what I'm going to do is I'll quickly look and just show places that might be near or record-breaking temperatures today, just because a couple people have asked. Again, not too many places, but again, it's the near coastal locations that are close to daily record highs in a couple of spots. Okay, so what I'm going to do is I'm going to take a break from the visuals and answer a few questions first, and then I'm going to get into the details of the forecast. So you're going to see me again on screen. Hello to the newcomers out there. All right, so I'm going to take the questions up through Elizabeth McDougall right now, and then I'll come back and do a second round of questions after I show the forecast. So let's see what we got here. Folks commenting that it is very hot. Just hit 100, says Susan, in Northern Marin. That is pretty hot for Northern Marin. Shashir, though, says onshore flow arrived early in Sunnyvale, so only 87. 4 degrees below forecast, although still considerably above the average for Sunnyvale in mid-September. So some local effects going on. 103 in Redlands, a lovely 68 in Half Moon Bay, which actually is pretty warm for Half Moon Bay, although this is the time of year when you would expect it. And then Zep mentions a perfect 85 in McLeod, which is, I believe, up in pretty far north, North State. Christina mentions it was 118 in Calexico last week. Not so much this week. Alex reflects, what's amazing to me about the elevated thunderstorms with the 10,000-foot cloud base is that the thermals that power these are not surface-based, but downdrafts certainly can become, surface-facing. So I think what Alex is referring to here is that you have these clouds that, when they're based 10,000 feet up, you look up and the bottom of the cloud is essentially 10,000 feet above where you are, right? The typical, the meteorology 101 version of how thunderstorms form is you have these bubbles of air, these thermals at the surface of the Earth that get progressively larger throughout the day. These thermals, they rise and fall, and they rise and fall, and they rise and fall until at some point they rise to the point where there's, the air actually has cooled enough that it can become, it can condense, and then it can start to rise spontaneously. So essentially, moist air cools at a slower rate, saturated air, I should say. So once a cloud starts to form and the air continues to ascend, it's cooling at a slower rate than the ambient air, and so therefore it remains warmer and buoyant than it, and then it continues to rise. That thermal reaches that point, that condensation point, where the air now becomes self-sustainingly ascending, and then it gets taller and taller, and that cloud gets more and more water condensed in it, forms a thunderstorm. Essentially, when you have a conditionally unstable atmosphere. Those surface-based rising thermals are sort of the progenitor of it. That's the meteorology 101 version of it. In this case, we don't have those rising thermals at the surface that are contributing. In fact, if you recall, in August 2020, and in a number of other elevated convection events, these are most common in autumn in California, you can actually have a stable marine layer. You can literally have marine fog in the lowest 1,000 feet of the atmosphere and have a high-base thunderstorm at 10,000 feet on top of it. So you have the opposite of thermals. You actually have a stable layer with a lid on it in the lowest levels. Those thermals are not escaping the marine layer. So what is transpiring with elevated convection is that it is completely independent of what's going on in the lower levels of the atmosphere. Marine layer is doing its thing, the fog is doing its thing, yada, yada, yada. But you get up to 10,000 feet and there's a layer of instability there. What that means, though, is you need some trigger other than random daytime heating. So you need some kick by the atmosphere, whether it's a short wave or some little packet of vorticity or spin in the atmosphere that induces just a little bit of initial upward motion to get it started. And then, it's kind of like a ball perched or a glass at the edge of precariously at the edge of a table. It's stable. It'll stay there unless somebody gives it a little push, a little wobble. But once you give it the push, it's going all the way. It's not just going to move as much as you pushed it. If you push something that's unstably perched at the edge of the table, it's just going to fall to the floor. So in this case, it's the opposite sense. You have that vertical motion, the ascent, that becomes self-sustaining. But in this case, it's largely independent of what's happening at the surface. And the reason that's interesting, as Alex mentions, is that, well, the thunderstorm formation process is almost completely independent of what happened at ground level. You're up and way up in the atmosphere that matters. But once you get those storms, you can actually have winds that make it all the way down through that 10,000 foot layer to the surface. And part of that is because of the process of evaporating precipitation. So you can have an asymmetric response where the storms themselves are ascending, beginning at about 10,000 feet and up. But when they start to collapse and send these downbursts downward, and as the rain starts to precipitate and evaporate and cools the air, you actually can get those strong gusty winds that make it all the way to the surface and cause problems. We saw that in 2020. We could potentially see that later this week, although it remains to be seen. But elevated convection is tricky because weather models don't do a very good job predicting it in most cases, which is one reason why I don't know exactly what's going to happen this week. And as I'll show you, different models are saying very different things, which is not surprising because that always happens in these kinds of patterns. This is a classic situation where the human touch, the human art of meteorology, comes in handy with visual and heuristic pattern recognition. And it's something that you would think you could train an AI model to do really well at representing, but thus far I haven't seen too many papers on this, although my colleagues recently published a paper using an AI model to recognize these signatures. So maybe the science has advanced while I've been buried in emails and virtual meetings the last few months. But in any case, yes, elevated convection is fascinating. It's poorly predicted. It's really a different flavor of thunderstorms than you get elsewhere in the country. There are a few places on Earth where it tends to be the flavor of storms, mostly in subtropical regions, actually, where you have a really hot and dry surface layer much of the time. But then you also have occasional intrusions of tropical moisture from the south, and sometimes those conditions can overlap, and you get this kind of setup where you have a lot of moisture and instability in the upper atmosphere, but not a lot of moisture and not a lot of instability in the surface level. Which again is the opposite setup of how it often is in most places that experience thunderstorms. Interestingly, during this event, by the way, Southern California may see thunderstorms that are closer to being surface-based, that more traditional surface thermal process, because it is going to be both warmer and moister and more unstable in the south. Southern California will be more squarely in the tropical moisture plume. Eric mentions that the HRRR is advertising PWAT, so precipitable waters, meaning the aggregate measure of the amount of water vapor in the entire atmospheric column, over 2 inches, which is indeed very high, tropical-like air mass, and severe thunderstorm soundings for much of Southern California. So essentially it's saying that the vertical characteristics of the air mass look like they might be conducive to severe storms. That's a good catch. This is actually something that's mentioned in the Weather Service Los Angeles discussion for later this week. There is a chance that there could be an isolated severe thunderstorm or two, so not just ordinary air mass thunderstorms, but even a thunderstorm that produces more intense conditions. Given the current characteristics, this isn't really a large hail kind of severe thunderstorm environment. The air aloft is not cold enough, I think, for that right now. But certainly torrential rainfall, frequent lightning, and then the severe piece comes in where there could be some strong wind gusts above 50 or 60 miles an hour. That would qualify it as a severe storm. And the Weather Service in LA even mentions the potential, slight, very slight potential, for a brief tornadic spin-up or two. That would also qualify as a severe thunderstorm. So those would probably be most likely as waterspouts offshore or right near shore. Something to keep an eye on. Not typical September conditions. Matthew mentions, but those high precipitable water values, concerns regarding widespread flash flooding. I don't think this is a pattern where there's enough large-scale forcing for any sort of widespread flash flooding. That said, there could certainly be localized, probably highly localized, but nonetheless potentially consequential flash flooding if and where an isolated, very torrential downpour manages to set up, and there could be a few of them. mainly in Southern California, but there is some chance, depending on how things go, and again, I'll show this, very different outcomes from very different models. This could extend up to parts of the Central Coast too. And also equally likely, perhaps more likely, that some of these very same places will remain nearly dry. So I can't tell you if you're on the Central Coast or Southern California if you're going to receive 0.01, barely enough to get your windshield wet, or in some cases, an inch or 3 of rain this week. I genuinely can't tell you, and I'm not sure that any forecaster would be able to pinpoint that in advance. But there will probably be places that see both, and it won't be constrained to the usual mountain versus coast dichotomy. Nicholas mentions a 62 and 63 degree dew point at Ocean Beach today. That's really high for Ocean Beach. And by the way, when you're that close to the ocean, when you're on the immediate beach, essentially, of the Great Pacific, the fire break, as the firefighters sometimes joke, to the west, when you're that close to the water and the dew point of the air, and again, the dew point is a measure of absolute humidity, so it is actually a very good measure of humidity. I generally prefer it to relative humidity, but don't tell anybody. 62 or 63 dew point pretty much means that the ocean temperature is very close to that, because often when you're in fog, the dew point should essentially be the air temperature, because you've reached the dew point. The air is condensing all around you in fog. If you're close to being foggy, the dew point should be close to the water temperature, and that means that the water temperature at Ocean Beach is probably around 60 degrees. That would be cold for LA, the pier at Santa Monica or La Jolla, San Diego or something, but for Ocean Beach, 60 degree water temperature is positively balmy. So it's often 10 degrees colder than that. Mary mentions that the recent news report does indeed seem to confirm that Korea also experienced its hottest summer on record. I don't really see how that couldn't be the case, given that the Korean Peninsula is surrounded on 3 sides by bathtub warm water at the moment. Perry mentions that the fog is behaving in a very unusual way in the Berkeley Hills and lingering even when it's relatively warm, and that is exactly what you would expect when the ocean is so warm that even though the air mass has warmed, the ocean kind of warmed with it, and you remain relatively close to that dew point. So the fog is still there, even as the ocean warmed, the air warmed. Usually in the fall, the air warms and the ocean stays roughly the same temperature, and so you start to get clearer, drier air. But in this case, the ocean warmed along with the atmosphere, and you're still near saturation point. All right, let's see here. Yeah, James mentions hot in Western Washington today, 90 degrees mid-September. That's not typical for Western Washington. Elizabeth mentions hot in Ukiah, 97 degrees yesterday, today about the same. Matthew mentions, my money's on muggy mid-level clouds and a few sprinkles on the SoCal coast. That's what usually happens with dying tropical systems. Well, some places probably will only experience that, but there is a higher ceiling on this one, and it is quite likely that at least a few places will see some pretty significant thunderstorm activity along the coast. So wherever you happen to be may or may not be in that category, but some spots probably will. But as you say, that is within the range of potential outcomes that the very divergent models are still suggesting. James mentioned SeaTac, the record high temperature up in the Pacific Northwest. Sarah asks, at what point this week do you think that the consumer weather forecast will be fairly accurate in predicting possible thunderstorms? The answer is I don't think they will ever be accurate this week in this kind of pattern, and this is just that complicated, and I think it's going to be a follow the radar kind of week. And just be aware that beginning later on Wednesday, but especially on Thursday or Friday, if you're from about the Bay Area southward, there's a decent chance there could be some unusual thunderstorms in your area, and keep an eye on the forecast. But I'm not sure we're going to get any more specific than in chances of showers and thunderstorms in different places. I think Californians are often used to a storm being a very contiguous mass of clouds that moves from west to east across the Pacific. That's one kind of storm. But there's another kind of storm, which is a convective storm, as we've been talking about today. These thunderstorms, individual cells sort of play their own game. And in this case, there isn't really a clear, large-scale focal point. So these are kind of just going to pop up locally in linear bands or isolated cells. And this is just not a pattern that the models have a good job representing. It's also worth noting that if you live in other parts of the world, it's not uncommon to have an afternoon summer forecast to be, a 30% chance of showers and thunderstorms essentially every day for 3 months. I'm exaggerating a little bit, but not by much if you're in a place like South Florida or other places that see frequent summer thunderstorms, for example. It doesn't mean that it's going to be exactly the same pattern every day. It just means that there is legitimately a 30% chance of storms every day, essentially, and it is not, even in theory, possible to predict exactly where they're going to pop up or which days might see more or less coverage, because it's an inherently random process in the atmosphere. Those are those random individual thermals. Does an eagle flap its wings, or is it a crow instead? I mean, it's a little bit of a contrived example, but perhaps it does illustrate that these tiny variations in microscopic levels of turbulence that aggregate over hours and days make it so that the exact location of the thermal that becomes the updraft that becomes the thunderstorm, we can't really pinpoint it in advance. And it's not really a modeling failure. It's actually just an intrinsic property of this kind of weather, that it may in fact be totally legitimate to say that we cannot be more specific than a 30% chance of thunderstorms on a given day in a general area. Sometimes we can be more specific, but in some patterns, I'm just not sure that we can. And this one is further complicated for a few reasons that I keep alluding to, and I'll show you in a minute. Yes, you can probably hear the birds outside the window here. Fortunately, that's the only real background noise at the moment. Otherwise, I'd close the window. Yeah, more comments of really notably humid air, high dew points, even inland. All right, and the last question I'm going to ask before I show the forecast maps that I know everyone's waiting for. Answer William. Speaking of the following radar, what is the time frame where the Bay Area ought to start looking at radars in terms of development? Well, I wouldn't bother looking at radar tonight, or maybe even tomorrow. Maybe late Wednesday night into Thursday would be the time frame. Probably early morning hours on Thursday would be the earliest you're going to see anything interesting. Of course, a bit earlier in the south, because it is coming from south to north in this case. Okay, so going to share my screen again. You're going to see a few things. Okay, I think I'm logged into what I need to be logged into, but bear with me. And because unusually we're only looking at the short term, I am actually going to use the operational model, not the ensemble. So for those of you who love the operational members of these model ensembles, which is to say the single iteration rather than the full plume of possible outcomes, well, this is for you. So here's the European model, the most recent update, and stepping forward in time, here we are right around now. So this is a current snapshot. You can see on this map, you can see the northern fringe of the decaying tropical storm on the south there. And then as I toggle forward a bit, so we're going to go here, this sort of answers the question about when. As we get into the early morning hours tomorrow, we're starting to see a few elevated sort of convective stuff off the coast. But so maybe if you look at, I don't know, the Vandenberg radar early tomorrow morning, you might see something way offshore, but nothing over land yet. And this just kind of sits around offshore as we get into morning. So this is right around sunrise. Again, more activity. So if you look again at the Vandenberg Air Force Base radar looking southwest, you might see something early tomorrow morning around sunrise. Could see some offshore thunderstorms. If you go to the beach on the central coast and look west, if there's no fog, you might actually be able to see some distant lightning flashes out over the ocean, but probably not over land. Going into Wednesday, we get into the late afternoon, early evening. Still, maybe a little bit of activity right down by San Diego and some offshore showers and elevated thunderstorms west of the central coast. If you can get up in the hills in the Bay Area tomorrow around sunset, you might have a good sunset because probably no storms over the Bay Area tomorrow, but if you can get up to a high enough elevation and look west or southwest, you might be able to see them out over the ocean safely 50 or 100 miles offshore. So it could be some good cloud watching, a good sunset. So sunset watch maybe for the central and south coast tomorrow. But we go into Wednesday night now, and this is where the model does start to show some of the activity potentially making it onshore. So some activity maybe in coastal Southern California as we get into the evening hours tomorrow. So this is, I guess this is a little earlier than I said. This is Wednesday night maybe in coastal Southern California. And actually some elevated convection, maybe even getting all the way up to at least in this particular model run from the European model up into the coastal North Bay after sunset tomorrow. So would this be in the form of just virga showers, rain showers that look pretty and essentially evaporate before they reach the ground, or in the form of some isolated elevated thunderstorms with some dry lightning? I don't know. I honestly don't know. Maybe. We'll just have to watch, and I'll be watching the radar tomorrow as well. We see more activity later tomorrow night. Maybe some isolated, virga showers or an isolated dry thunderstorm up toward the Bay Area. But mostly this activity is wetter storms and still mostly offshore, although there could be some rain. We see some returns over Orange and Los Angeles County tomorrow evening, so this could be the first significant activity. But it's really in the overnight hours tomorrow night, as I mentioned, where some of this probably starts to move inland. So we're seeing more intense simulated refractivity. These are probably thunderstorms over Orange and LA County. Overnight early morning hours on Thursday, starting to move up the central coast as well, potentially. And then as we go into the day on Thursday, now again, this is just one model snapshot, but this is showing a fair bit of convective activity and potential showers and thunderstorms moving up throughout all of the central coast and even into southern and eastern portions of the Bay Area. And this would be right around sunset on Thursday, so about 48 hours from now. And again, the European model suggests that could extend across much of the San Francisco Bay Area, into the San Joaquin Valley, into the Sierra foothills, maybe even focusing on the central coast as opposed to Southern California, at least once we get into the later evening on Thursday. And as I continue to step through, here's Friday morning. That's a fair bit of activity in Northern California. This now includes the San Francisco North Bay, potentially the Sacramento region, really the Central Valley. This is frankly a pretty active picture. It does not necessarily mean that all these places will be seeing rain. Some of this precipitation will be elevated convection, the rain that is evaporating before it reaches the ground. That could just produce pretty clouds and sprinkles and gusty winds, or it could potentially produce some dry thunderstorms, especially up here. As we go down here, these thunderstorms would likely be wetter. But I'm just continuing to toggle. We get into Friday evening. This activity is starting to shift inland, so less going on in Southern California, but there is some in Northern and Eastern California. These, again, could be thunderstorms here. And then things quiet down as we get into Saturday morning. So pretty quiet day, it looks like, on Saturday. But then, take a look at what happens early next week, about a week from now, potentially. An offshore low-pressure system, and we've seen this for several model cycles now. No precipitation associated with the low itself, but when I toggle over to, let's look what happens when I look at, for example, the precipitable water, the amount of moisture, oh wow, there's a bunch of tropical moisture. Whoops, that's not what I meant to do. So this low pressure system picks up a bunch of subtropical moisture that was lingering over California and moves it inland, potentially by early next week. And look at what this does over Northern California. It pops up a line of pretty heavy thunderstorms across Northern California. This would be a separate thunderstorm event in about a week from now. Even more uncertainty with this. We started seeing it pop up for several model cycles now. Let's go to the American model, see how this looks. Again, I'm going back in time. Here's right now. Here's tonight into tomorrow. You see that offshore activity I was mentioning kind of fading a little bit. Not much going on still. Maybe some stuff by sunset tomorrow making it into coastal Southern California. Nothing off of Northern California. And the American model shifts. This most recent cycle is less active. So we do get activity from about Ventura County south and eastward. And so this could be showers and thunderstorms, probably wet ones. Not a lot going on up on the Central Coast and the Bay Area northward with the American model. So this is a pretty significant difference. In fact, little or nothing going on according to the American model. So although interestingly, it too does the same thing early next week with a pretty major thunderstorm outbreak right around next Monday or Tuesday over Northern California. This would be a pretty notable thunderstorm outbreak. Before moving on, we get to a warmer, drier pattern. Okay, so that's two very different outcomes. Now let's look at the ensemble for total accumulated precipitation. Here's the European ensemble. This is all of the different numbers, all of the different potential outcomes. Okay, so this is kind of interesting in that it's showing a bullseye along the Central Coast. So perhaps the most likely place to see a wetting rainfall is right along the Central Coast. That would not be such a bad thing. But there is some precipitation plotted across really all of California, so we can't rule out some showers or thunderstorms anywhere in the state. But right now, the European ensemble says the southern Central Coast, so San Luis Obispo, Santa Barbara, maybe Ventura counties being the most likely spots, but it could certainly occur elsewhere. If I look at the American model ensemble, this is a bit different. Similar amounts, but shifted more southeastward, more toward LA County south through San Diego County. Substantive amounts. Still not zero, but a lot less as we get up into Northern California. Okay, let's look at a high-resolution model, the high-resolution rapid refresh model, for example. Let's look at the most recent update cycle here. Okay, so what does this look like as this former tropical storm moves northward? Well, you can see again, a lot of that activity is offshore, brings some activity to the nearshore waters, that sprinkle and virga that people talked about, but heavier stuff offshore. And then there's a couple of bands of heavier showers and thunderstorms, again, by the nighttime hours tomorrow. This looks like it's kind of splitting the difference. And I know this only goes out through Thursday morning with this particular model. So let's go to a slightly longer one. So here's another high resolution model, but a different one showing a bit of a similar picture, keeping things mostly east of the Bay Area, but again, this is farther west. This would affect the Central Coast more, the Central Valley more, and this gets us through Friday where things still aren't done. Let's look at a slightly coarser model that brings us out even farther. Again, looking at this representation, this might not be the best visualization of it. So what I'm seeing from this is that the overall consensus is that there is a bit less likelihood of dry thunderstorms in the Bay Area and the Central Coast than there was when I wrote the blog post yesterday, for example. So I think that's generally good news. They are cool clouds, but honestly, these days, dry thunderstorms bring so many problems from a fire perspective that probably better off without them. So don't get me wrong, they could still happen, and our single best weather model, the European model, actually is the one that's suggesting the highest odds of it. But the rest of them aren't. They're showing a much more southeastward and muted focus, which would still bring a pretty high likelihood of some thunderstorms to much of coastal Southern California, especially from Santa Barbara south to the Mexican border. But there's still a pretty high uncertainty regarding how this might play out. To illustrate this, let's take a look at a few decision points So let's take a look, I don't know, Central Valley growers. Let's look at the 15-day precipitation matrix for Davis. Again, so here's that first system. Well, actually, let me show it in this form instead. This is going to be easier to interpret. Oh, and I think I might still be stuck on the. Just give me a moment here. So here we've got, well, from the European model at least, that's showing the greater northward and inland extent of the moisture. There's a pretty high odds of measurable precipitation in the Central Valley. So this is for Davis. The average is just a tenth or two, but that's measurable, and this could be in the form of elevated thunderstorms and convection. That's a more than half the model members have something in Davis. Although again, a lot of them are. Some of them are still completely dry, so can't rule out either of those scenarios. Also notice that a fair number of these ensemble members are showing that other thunderstorm outbreak early next week that I mentioned, although there's less confidence. There are a greater number of completely dry members here. But this is a more active September map than you'd typically see. Let's look at a few other places. Let's look at, I'm trying to pull up, say, San Francisco. You would think that these would be perfectly alphabetical in the list, but they are in fact not. Here we go. They're semi-alphabetical. Here's San Francisco. Again, the European model suggesting a pretty high odds of something happening Thursday or Friday, but there's a wide range. This would be a really heavy thunderstorm downpour, so would this and this. But again, these would be completely dry, all these white ones, and the gray ones would be just sprinkles, elevated convection, maybe dry thunderstorms. So again, wide range of outcomes, and we see that again for early next week with those additional potential thunderstorms. What happens though if we look at LA? I'm trying to remember where it was in this semi-alphabetical list. Unfortunately, there really is no faster way than me scrolling, so I apologize. LMNOP. I still have to sing the alphabet song when I alphabetize. I don't think getting a PhD changes that. Okay, here's LA. All right, so LA, you can see much higher confidence and probably on average higher amounts. So a pretty good chance of some real rain in the LA area. Most members of the European ensemble suggest something. Although again, even here, there's a couple that are still completely dry or nearly dry. But the odds of getting a heavy downpour in LA are a lot higher. And again, there's a few members that bring multiple inches of rain. There's also members that are completely dry. That's why I'm kind of throwing my hands up. And in this case, I'm not surprised. I don't think this is a failure of the model. I just think this is an intrinsically uncertain pattern. Does a thunderstorm pop up and run over LAX where the rain gauge is, or does it not? Will the right crow flap its wings? I don't know. Okay, so I think what I'm going to do is I'm going to go back to answering some questions as we've now gotten to the hour. Make sure I've gotten that right there. Yep. All right, folks, so if you have questions, this is a good time to ask them since I'm going to be wrapping up soon. So I'm going to go through the questions. I do think I will probably, unless we end up on the very unexpectedly inactive side of the forecast spectrum later this week, I will probably have another live stream later at a time TBD to coincide with active weather. So I'll show satellite and probably radar, and I bet you I'll be able to show you some lightning occurring live on screen. So we'll see. Don't know when that would be. Probably not tomorrow. That would probably be Thursday or Friday. Looks like there was a little bit of excitement in the chat while I was not looking at it. So, by the way, folks, when that happens, you can flag it and move on. That's always the best and most effective response to trolling. Okay, so in terms of questions, not too many. So again, this is your chance. I'm gonna stay on for 5 or 10 more minutes if there are questions. So there's less than 10 minutes left of questions in the list right now. Once in a weekly opportunity, maybe. Patrick mentions, the Seattle, the SeaTac being the airport there, the record high for this date is 90 degrees Fahrenheit, set 1967. Thus far, today's high so far of 90 should at least tie it sounds like. We might well break the daily record the next hour, since often the high temperature is between 4 and 5 p.m. this time of year, so that is indeed quite possible. There's a comment, the higher than average dew points have had a notable effect as well on moderating temperatures. That is true. Nights have been warmer than average. A number of days inland has been fewer. Well, what's interesting is I actually don't think it's had much of an effect on the days above 100 because it's only recently the ocean has been warmer than average. It was actually much cooler than average for much of the summer. So I do think it's moderating temperatures now, although moderating is relative. It actually does definitely mean that the average temperatures are warmer by virtue of the ocean being warmer. It may mean that you shave a couple of degrees off the high temperatures during heat waves. That's true, but the larger effect is that your overnight temperatures stay significantly warmer, and they do so every single night. You don't really get those cool, crisp nights to the same extent, at least along the immediate coast or in coast-influenced inland areas, places that are inland of the Carquinez Strait, so like the Delta region, for example. So the moisture air, don't get me wrong, definitely has a moderating effect on temperature because it means it's drier air tends to, it requires less energy to heat dry air, and it also means that dry air can lose that heat faster as well at night. So you can have a larger diurnal swing when the air is dry, cool and crisp air, and hot and dry air. People say, the air is cool and crisp and the air is hot and dry. Well, there's a reason why we have those sayings for both hot and cool, is that it does tend to expand the range on Earth of what is possible, and you do get muted temperatures. But in general, around here, when you get an unusually warm ocean, it does shift the average temperature upward because you're shifting the overnight temperatures upward more than you're shifting the daytime temperatures down. But it is true that it is an overall moderating effect. It's a good observation. James Redding mentions that there was 2 to 4 inches of rain I think this is a prediction. The 2 to 4 inches of rain for the Olympics up in Washington this coming Sunday. So it's a little while out. There's some active fires up there now, but yes, that should really help with fire season up there. It's about time. Getting into the second half of September, it would be pretty unusual to go much longer without that water. There's a comment that the Los Padres mountains and forest of Santa Barbara and San Luis Obispo counties look like they'll be a target for more wildfires. I'm really not super concerned. There could be some wildfire starts there, but it's equally likely that these storms will be on the wetter side there. So it's a mix of wet and dry, and what follows is not a particularly alarming pattern if we do get some fires. So I'm not really emphasizing the fire weather threat with this, even though there is some. It's not zero, it's elevated, but it's significantly mitigated by both the background lack of drought and also the fact that wetter showers and storms would most likely follow the initial drier ones, probably. Could be some surprises, as I say. Question from Mark Ikeda, is there any chance of training thunderstorms? So thunderstorms that move like a train on tracks over exactly the same region over and over again. There is a little bit of southwest and northeastern sort of parallel trajectory, so maybe, but and that if that happens, there's a slight chance that would enhance the flash flood threat in a very local sense in Southern California. So I'd say slight chance. So there's a slight chance of both a couple of severe thunderstorms, of a couple of flash flood events, of a couple of dry lightning episodes. Mixed bag, we'll see what we get. So there's at least a slight chance, although it doesn't look like a really concerning widespread event from that perspective. Jim asks, I think I was in reference to what I was talking about earlier, why would there be a better sense that at higher elevations we'd not see at sea level? Well, if you're at sea level anywhere but the immediate coast, in northern and central California, there are mountains that are going to block your horizon view because of the coast ranges. So if you're at the beach, obviously looking westward, there's no mountains between you and the ocean. But if you're anywhere east of the coast ranges or in the coast ranges, you can't see the horizon. And these storms offshore would be low enough on the horizon that you'd want to be able to see the horizon. The other reason is that there might still be a bit of a fog bank, if not on the coast, at least off the coast. And so if you get up even just a few hundred feet, you'd probably be up above that. And this is elevated convection. And so I know some folks have gotten pretty amazing photographs, especially at night or in the late evening hours, of these large thunderstorm clouds above the marine layer. You can actually get a photo of this fog, if you're lucky, in the foreground and the lower elevation, and above it or in the distance, and these elevated thunderstorms with 10,000 foot cloud bases with lightning coming out of them in the distance. Usually I don't advocate going and sitting outside during thunderstorms because of the obvious risk of being struck by lightning, which is usually the greatest risk of thunderstorms when they occur in California. But in this particular case, if they start popping up tomorrow evening, south and west of the Central Coast and the Bay Area, they will likely be quite far offshore. So you'd be pretty safe if you're up in the coastal hills looking west, for example, tomorrow evening around sunset and looking south and west from maybe the Bay Area southward or westward. So, potential photographic opportunity without much lightning risk. Obviously, if the forecast ends up being wrong and there's lightning that's close to you, probably not the best idea to be outside. But I think and later in the week, there could be interesting clouds, but they're more likely to be essentially right overhead. So, I would not necessarily advocate going out and gawking at the lightning-producing clouds when they're on top of you. Like a question about what are my thoughts on the experimental CAMs, the essentially the convection resolving models, so the high resolution models that can, they're usually used to better represent things like thunderstorms, fine scale processes. I use them to some extent, although so we did look at we looked at the HRRR. I didn't look at these other ones. They're pretty heavily tuned to representing surface-based convection because that's what's most common in the central plains of the U.S., where these models are most useful for severe thunderstorm outbreaks, tornado outbreaks. To be honest, I actually haven't looked at them very much in the context of elevated convections. That's a good question. Maybe I'll take a glance at them after my next round of meetings this evening. See what they show for this week, just so we have a sense of the comparison to what actually happens. So maybe you'll see me showcase them the next live stream this week if they show something interesting, but I wouldn't be too surprised. Elevated convection is difficult because most of the relevant processes, again, are occurring way above the surface, which is very different from how thunderstorms usually evolve. So we'll see. No, yes, I wish we could train thunderstorms to do what we want, but sadly, that's not what we mean by training thunderstorms. All right, well, and thanks folks, Danny and others, to the congratulations regarding the GRIST 50 list. It's an honor, and it's always gratifying to see when the word gets out about these conversations that we're having about weather and climate change and wildfire and public policy as it intersects all of these things. So it's partly thanks to these sorts of venues like we're inhabiting right now with this YouTube live stream, that was possible. And I know a fair few journalists tune into these live streams, so thank you as well, because that's a big part of my job, is to have these conversations in public. And again, I'm glad that University of California Agriculture and Natural Resources, so UCANR, is allowing me to be gainfully employed and still doing this. These days, certainly no guarantee of that, especially in this moment. So again, I'm glad for that. I'm glad to still be here, and thank you all. So on that note, prepare for an interesting sunset tomorrow. Hopefully the balance of wet storms to dry storms will be more on the wetter side, less on the lightning fire-inducing side, without having too much flash flooding. Beware of lightning, but also keep in mind there could be some good cloud observing and photography opportunities tomorrow, depending on where you look, and maybe over the weekend and even into early next week. Be keeping an eye on that secondary system next week, because that looks quite interesting, and it keeps popping up in a lot of these model runs, so be keeping an eye on that as well. It is, I will say, nicer to be talking about this than a huge wildfire outbreak. I think most people would probably agree with that. All right, see you probably later this week at a point TBD. If you want to be notified, you can subscribe to the Weather West channel and then turn notifications on. That's a critical second step that is not automatic, and I think folks sometimes miss. Or you can follow me on other social media channels, and even if they're on short notice, I will post there that I'm going live shortly as well. So, all right, see you next time, and keep an eye to the sky.